Proving each identity. So here's A. We have cotangent theta plus tangent of theta equals cosecant theta secant theta. Draw our line. Now that we've been introduced to the Pythagorean identities, sometimes you're going to say, maybe I can change something with a Pythagorean identity. Some things to be careful with the Pythagorean identities. They only happen if you have something squared. Can you see that currently we have nothing squared? So since nothing is squared, this makes sense to start off by going back to one of our basic strategies, changing things to sine and cos. So if I change cotangent, can you see that that would be cos theta over sine theta? Plus tangent would be sine theta over cos theta. On this side, cosecant is 1 over sine theta, and secant is 1 over cos theta. After changing everything to sine and cos, I hope you can see that the two sides are not identical yet. Then we use our other main strategy, which is take your fraction skills, write both sides as a single fraction. So on the left side, I'm adding fractions. How do you add fractions? Common denominator. So what's the common denominator between sine theta and cos theta? Sine theta cos theta. So I would need to multiply this first one by cos theta and cos theta, and this second one by sine theta and sine theta. That would get me a common denominator. Okay, and what thing did I come by on your proof earlier and say that would be an E3? What did you do? He forgot the thetas. He was like, oh, I'm just multiplying by cos and cos. It's so annoying to write the extra theta. So he just wrote cos, cos, sine, sine. That will always be an E3 error. If you forget a theta once, you get an E3 error. So you have to write it every single time, or whatever variable it is. And that's a half mark on the exam. So now we have our common denominator of sine theta cos theta. And on the top, how do we add fractions? Once you have a common denominator, you add or subtract the tops. So the top will be cos squared theta plus sine squared theta. On the right-hand side, it's not a single fraction yet because we have a fraction multiplied by a fraction. How do you multiply fractions? Multiply the numerators. 1 times 1 is 1. Multiply the denominators, so we get sine theta cos theta. We're getting closer. Now we have a single fraction on both sides. And up till now, almost all of our proofs would be done, but this one's not quite equal. But do you notice that your denominators are the same? Is there anything you can change your numerator to? Yes. Here's the big idea. Here's the first Pythagorean identity. Sine squared plus cos squared is equal to 1. So we can just change that to 1. And we're done our proof. Yes?
So, like, on the left-hand side, do you have to show that it equals 1, or can you just write it how you want? Like, do you know what I mean?
You have to, in the end, whatever I write on this side has to be identical to what I write on this side.
So you don't have to do, like, okay, you don't have to show that cos squared theta plus sine squared theta equals 1. You can just write it as
You can just, anything that's on our formula sheet, like I said, so we have sine squared plus cos squared equals 1. You're able to just directly change that to 1.
We have to have the exact same thing as the end result on both sides.
Yes, the end result on both sides has to be identical. You can't just go, oh, I know this is the same in my head, and go left side equals right side without writing it down first, that they're identical. B. Oh my goodness, there's a cubed. Do you know what that means? This is going to be harder. It just seems scary with that cube there. Do you want to see the 3-page proof of this one or the 3-line proof? 3-line proof? Okay. So, the shortcut for this one, the 3-line proof, is to say to yourself, hey, this side is in cotangent. The other side has cotangent and a cosecant squared. What can you do with cosecant squared? There's a relationship between cosecant squared and cotangent. Cosecant squared is cotangent squared plus 1. So if I start by changing the cosecant squared to cotangent squared theta plus 1, sorry, say that question again.
Do you have to put like cotangent in the brackets, cotangent squared theta plus 1?
Yeah, because what we're doing is we're substituting this for this using our new identity, because cosecant squared is equal to cotangent squared plus 1. What can I do here? I can distribute this, right? That would give me cotangent cubed theta plus cotangent theta minus cotangent theta. Those will cancel out. And we're done. 3 lines. What's the 3-page proof? If you change everything to sine and cos and try to get a single fraction, it will take a lot longer. It will work. It will work, but you will have to do a lot more work. So sometimes if we can notice things, and so every single thing that is on your formula sheet for identities, you have to have memorized. Because the fact that it's on your formula sheet, if you have to look for it, you will miss it in a question like this. And you'll just change to sine and cos, and you will do the 3-page proof, which is not wrong. And you won't lose marks for having 3 pages instead of 3 lines. But this is a lot quicker. Yes?
Is our formula sheet like labeled identities, whatever, stuff like that, or is it just like literally a page with a bunch of formulas?
It's just a page with a bunch of formulas. They do go in order. So the formulas S equals theta r was our first formula. And then sine squared plus cos squared equals 1 is the second formula on your formula sheet. Did I give you a formula sheet? I haven't? Oh, well, happy birthday to you guys. I'll give you one right now. We are going to add a part C.
Why?
Okay? Don't write that down in the green box. That's just to make it an advanced proof.
How do I have
Write it. Are we going to need to write anything for the thing?
No, you can write this under the think further. Add it at the bottom of the page. It is a power of 4. Tan to the 4 minus secant to the 4 equals negative tan squared minus secant squared.
I don't suppose this one has a 3-line proof.
It does. It has a 3-line proof and a 4-page proof. So
Wait, Mr. Joe, was that tan cubed squared? The thing in the
no, don't put the thing in the green box. That's as if I could, instead of writing negative tan squared minus secant squared, I could have written this as negative sine squared minus 1 all over cos squared and made it a much harder proof. But we're just going to do the easy proof.
Is the exponent next to negative 10, is that a 2 or a 3?
That's a 2. That's a good question. Okay. We'll make this nicer.
I thought you were going to say harder.
There it is, a beautiful 2 now. Oh, happiness is making nice 2s.
Okay.
Did you just get up and make a really nice 2?
Yeah. Oh. I've actually been lately quite disappointed in my 5s. Yeah.
My fives look like S's.
And yeah, they look like S's. They're not. They're, and you guys keep losing half marks, and so I have to make so many fives. And every time I make a 5, I get angry. So I'm like, it didn't used to be a problem, but I'm like, something's wrong with my penmanship right now with 5s. So I'm trying to retrain my hand to make nicer 5s.
Write 500 5s.
No, I'd say, and on the board is different. Like on the board, I'm fine. That is a nice looking 5. That's perfectly okay, right? As soon as I'm on a piece of paper, they go like that. You see, this is the issue right here that I'm having, is that part of my 5. I don't have that little, like,
Just need to start from the top.
I know, I start from the top, but my hand, oh, so it's like,
No, do this.
see, it needs this little, well, I've done that, but I feel like, oh, I want to do the down first over and I like,
That's how I've
see, but I've been, you'll notice some of your 5s on your quizzes have been from the top over because I'm so frustrated with this. Sorry, there's my 5 issues for the day, but,
Like jotted.
okay.
Jotted
My 2s used to,
Real math struggles.
the math teacher struggles. It used to be the 2 because I'd be writing 2s fast and they start going like that, right? So I've been really focusing on doing the loop. The loop feels better for me. Oh, right. When I was in grade 7, we had drafting class, and in drafting class you have to make numbers certain ways. So like the 2 had to be like this. Okay? And the 7 had to be like that. For
deadass looks like the numbering, like the
the 3s had to be like this for drafting.
Oh, that's so nice.
Oh, that is a nice 3. That is a perfect 3.
That circle's pretty good, isn't it? Right? We're gonna keep that 3 for later, but the rest we can
If he ever needs to write a 3, just paste.
just paste that 3.
Question is question 3.
Okay. Now, to prove this one, we have to use some advanced factoring skills that we learned back in grade 10. So they're not really advanced anymore. Yes, you did learn them in grade 10. If you look on the left, it is a special type of binomial. It is a difference of squares. What times what would give you tan to the 4? Tan squared and tan squared. What times what gives you secant to the 4? Secant squared and secant squared. One will be plus, one will be minus. Yes.
If you had like one that wasn't the difference, but it was like adding them, would it just be like tan squared plus secant squared and then tan squared plus secant squared again? Like, would it
No. If it was adding, you can't factor it. It's only a difference of squares that you can factor.
I thought you called me Nicholas.
So question, we've got a whole bunch of tan squareds and secant squareds. Could I rearrange my tan squared plus 1 equals secant squared formula? Could I rearrange it to get tan squared plus secant squared, or could I rearrange it to get tan squared minus secant squared? Which one? Or both of them? I can get tan squared minus secant squared by rearranging things. Okay? If I get tan squared minus secant squared by rearranging things, what would be on the other side if I moved? Minus 1. So there is our next step. Tan squared minus secant squared is minus 1. Okay, take a look at tan squared. I'll write it over here. Here's our formula on our formula sheet. Can you do mental math to get tan squared minus secant squared on one side? What would be on the right-hand side then? The minus 1. because you would have to move the 1 over to this side and the secant squared over to that side to get tan squared minus secant squared. So I can change tan squared minus secant squared to minus 1. If I then distribute my negative, I'm done. Yes. Taryn, you had a question? Okay. And then if you changed tan squared to sine squared over cos squared and secant squared to 1 over cos squared, you could combine it to be a single fraction and get what's inside the green box. But that would be a harder proof, because if I would have started the proof off that way, you would have been very tempted to change everything to sine and cos at the beginning.
Wait, how did you get that fraction?
I changed tan squared to sine squared over cos squared, secant squared to 1 over cos squared. They would have a common denominator, so I could write it all over cos squared and just add the tops. Hey, questions for practice out of your textbook are 3, 5, 6 II, 7 II, 9 II.